In this final video for Chapter 1, we're going to compare observational studies to controlled experiments. So the book defines observational studies as studies where subjects are put into groups either by their own actions or by the decision of someone else not involved in the study. To me, it makes sense to think about it as observing what naturally occurs without any outside influence. You're just going to see what's naturally occurring. You're not influencing anybody one way or the other. And now after an observational study is conducted, it's appropriate to conclude that there is a link or an association between the two variables that you studied. However, it is not appropriate to conclude that one variable causes another variable to change. You can't use the word cause. You can't say there's a cause-effect relationship because there may be a confounding variable. So in observational studies, there may be a variable that we didn't study, we didn't ask about, but it explains what we saw in our results. And again, that's known as a confounding variable. So let's say, for example, we notice a trend that as people drink more hot chocolate, the crime in their neighborhood goes down. But as people drink less and less hot chocolate, the crime in their neighborhood tends to go up. Now, we can't say that hot chocolate is causing this increase or decrease in crime. That doesn't make any sense. We don't use the word cause. We can say there's a link between hot chocolate consumption and crime in this neighborhood, but we can't say that hot chocolate is driving this crime rate because there's a confounding variable, and that confounding variable would be the season. In the fall and the winter, it's typically cooler and people drink more hot chocolate. But also during those seasons, because it's cooler, people aren't out as much, so that there's less crime. People are home more, so people aren't going to break in when you're there as well. Criminals like to stay in because it's cold outside. But when it warms up, people quit drinking hot chocolate, but they also go out more. There's more of a chance you would be broken into when you're not home as well. Criminals are out when it's warmer. It's pleasant outside, so they're outside as well. So that would be a confounding variable. Now, opposite of an observation will be a controlled experiment. In a controlled experiment, researchers take control by assigning subjects to a control group or a treatment group. So there is some outside influence here. You could say, okay, we're going to study this particular drug. We want to see, does this new drug work? So we would put people into different groups. The first group would be our control group. They don't get this new drug that we're studying. The second group would be the treatment group. They would get the drug, and we can compare the results. So we're influencing this. It's not just an observation, but it is an experiment. Now, after conducting a controlled experiment, it is appropriate to conclude there's causality between the two variables. You can say there's a cause and effect relationship because you're controlling everything except this one variable, the treatment. It can be said that the treatment or explanatory variable causes the change in the outcome or the response variable. Here are some properties of good controlled experiments. You want to have as many of these as possible. So let's say we've got a drug study we want to conduct. So we're going to do an experiment. I have this new miracle drug that I think will cure the common cold. If you start to feel sick, you start to sneeze, you start to cough, nose gets runny, you take this pill, your cold goes away, never get the cold. So I would want to have these properties. Number one, I need a treatment group. I would need the group of people who actually get my drug to see, is my drug working? I would compare that to a control group, a different set of people who do not receive the treatment. So these people have a cold, but they don't get the miracle drug. They don't get any drug. They're a comparison group. Now, if you can, it's nice to have a third group, a placebo group. They would get a placebo. It's a harmless pill or a sham procedure that the subject believes to be effective. So my third group, they would get some pill that maybe looks like the miracle drug I've created, but it's just a sugar pill or it's water inside the gel. It doesn't make any difference. It's all psychological. So I would have my three groups, and I've placed people into these groups. I'm influencing what they do. You're going to take this pill for your cold. You can't take anything for your cold. You're going to get this pill for your cold, but it's a placebo. They don't know that. Next, I want a large amount of subjects. In general, the larger the sample size, the better. The more people you can talk to, the better your results will be for the most part. We'll talk about certain numbers in some later chapters. We always want an element of randomness with our experiments as well as our observations. We want to randomly select people, and we want to randomly put them into the groups. This assures that our groups look similar. We're not breaking the groups apart by a certain characteristic, but we want all kinds of people in all of the groups. So we randomly select people, as well as for an observation, you want to randomly select those who participate. The final two are related. You've got blinding first, where subjects are not aware of their group and the other groups in the experiment, because we don't want them to influence one another. They're not aware of their group. If you know that you're in the placebo group, then you know that you shouldn't feel any effect, and that's going to affect our results. If you know you're in the treatment group getting this miracle drug, well, that might influence you psychologically to think that, hey, this is going to cure my cold. So we want to avoid people knowing what groups they're in. As well, sometimes you want double blinding. The researchers nor the participants know which groups and which subjects participate. There's a third party involved. And this comes down to ethics. You may invest a lot of time and a lot of money in this wonder drug that's supposed to cure the common cold. So you've put years of your life into this. You've put millions of dollars into this. You might be a little bit biased in wanting your drug to work. So when you collect the data, you might ask the treatment group people, oh, you look great. Don't you feel good after taking that pill? And you might ask the placebo users, you don't look so good. How do you feel? And that would influence their response possibly. So in order to get good results, good data, we would have a third party come in and collect our data for us and ask the questions. So those who may be biased don't influence what's going on. So we've got observations where we just observe what naturally occurs. We've got experiments where we put people into groups and we sort of control what they do. They take this miracle drug, you drink this amount of coffee per day, or whatever it may be. So let's wrap this up with one example. There was a report that stated that ice cream consumption is related to the number of people who drown at the beach. The report went on to say that as the amount of ice cream consumed increases, the number of people drowning also increases. So to reduce the number of people who drown, the amount of ice cream consumed needs to be reduced. Does this make sense? And your answer should immediately be no. This does not make sense. Reducing the amount of ice cream consumed is not going to reduce the number of drownings at the beach. There's a confounding variable here. This is just an observation. When the weather is warmer, people eat more ice cream, people go to the beach more often, and therefore there are more drownings. When it's cooler, say in December and January, people are eating less ice cream, and fewer people are going to the beach, therefore there are fewer drownings. We can't say that ice cream is causing this trend in drownings. It wasn't an experiment. This was clearly just an observation. So keep those two types of studies in mind throughout the course.